Number 60 is a pretty awful looking thing, honestly, that comes from calculus. It's called a difference quotient, and it's something that you'll use in calculus to find what's called a derivative, and so it's good to know this kind of algebra for when you get there. First of all, though, we just want to try and divide these two and get it down to just one fraction as possible, which we will be able to do. And you can either use method 1 or method 2 from that last example we did in our notes. I prefer method 2, so I'm going to do it that way. What that means is I'm going to consider just the top and bottom separately, try and get a common denominator in the top and combine them. The bottom is just h, I don't even need to get a common denominator, so it should be pretty easy. So my common denominator in the top, I just want to make sure it includes each factor that is included in the top. It would be x plus h, x plus 1. So I'm going to have something over x plus h, x plus 1, minus something over x plus h, x plus 1. Now looking at what I had compared to what I have now, I now picked up an extra x plus 1, so this is going to be x plus h plus 1, multiplied by the extra x plus 1 that I picked up. Here I had just an x plus 1, I picked up an extra x plus h, so x times x plus h, all over h. Now I'm going to go ahead, because I have the same denominator, I have a common denominator, I can combine these, and I'm going to combine these two and FOIL them. So notice this one's going to be a little tough because I have to make sure I do all of these when I FOIL it. So x times x is x squared, plus xh, plus h, plus x plus 1, minus, now I need to be careful here, this is a minus x that I'm distributing through the parentheses. So minus x squared minus xh, all over x plus h, x plus 1, all of that over h. So I FOILed that first thing, the thing I'm highlighting in blue now, I distributed that, and then I made sure to distribute the negative x through what I'm highlighting in green there. Okay, so now let's go ahead and combine like terms together. Notice that the x squareds cancel, so that's nice. The xh's cancel, so that's also nice. So if I write what's left over, x plus h plus x plus 1. That's 2x plus h plus 1 over x plus h, x plus 1, all over h. So I've gotten it down to one fraction in the top. Well, once I have it down to a fraction over a fraction, right, I can think of h as h over 1. I can divide the two. And dividing fractions, as I always say, is easy as pie. Just flip the second fraction and multiply. So times 1 over h. And there are no factors to cancel anywhere, so I just multiply straight across. 2x plus h plus 1 over h times x plus h times x plus 1, and that's the best we can do.